Bismillahirrahmanirrahim. Welcome back to another video. In this video I'm going to do exercise 2.1. Here we have question number 5 from exercise 2.1. Determine the nature of root of the following quadratic equation and verify the result by solving them. First we have to find out the roots of the given quadratic equation. So we are given 3x squared minus 10x plus 3 is equal to 0. So quadratic equation. First we have to compare the given quadratic equation with the general form of quadratic equation, which is ax squared plus bx plus c is equal to 0. Now to do the comparison of equation 1 and equation 2, we get a is equal to 3, b is equal to minus 10, and c is equal to 3. Here we have to find out the discriminant of the given quadratic equation. So we know that the discriminant is equal to b squared minus 4ac. Now to put the values of a, b, c from here, so we get minus 10 into whole square minus 4 into 3 into 3, so we get 100 minus 4 312, and 312 is 36, so it's equal to 64, which is greater than 0, since the discriminant, the root is real. Since the root is real and a perfect square. Now we have to solve the given quadratic equation. Now we have to verify the given quadratic equation, which is 3x squared minus 10x plus 3 is equal to 0. We can solve this quadratic equation by different methods like factorization, completing the square, or quadratic formula, but we will look which way is easy to solve the given quadratic equation. Here we have to solve the given quadratic equation by factorization. Thus it's easy to solve the quadratic equation by factorization. So if we write 3x squared minus 9x minus x plus 3 is equal to 0, because we split 10 into minus 9 minus x, because if we add minus 9 minus x, we get minus 10x. If we multiply, we get 9x squared. So now we take 3x common from these two, so we get 3x minus 3, and from here we take minus 1 as a common, so x minus 3 is equal to 0. X minus 3 into 3, x minus 1 is equal to 0. Now by zero factor property, we can write x minus 3 is equal to 0, or x is equal to 3. If we add 3 both sides, so we get x is equal to 3, and 3x minus 1 is equal to 0. Now if we add 1 both sides, we get x is equal to 1. Now divide by 3, so we get x is equal to 3, and from here we get x is equal to 1 over 3. So the solution is 3, solution set is 3 and 1 over 3, and hence we verify the given quadratic equation. Now let's take one more example, which is x squared minus 6x plus 4 is equal to 0. We are given a quadratic equation. First we have to find out the root. So to find out the root, first we have to compare this equation with the general form of quadratic equation, and then we know that the general form of quadratic equation is a x squared plus bx plus c is equal to 0. Now to do the comparison of equation 1 and equation 2, we get a is equal to 1, b is equal to minus 6, and c is equal to 4. Now we have to find out the discriminant. So the discriminant is equal to b square minus 4ac. Now put the values of b, a, and c. We get minus 6 into whole square minus 4 into 1 into 4. From here we get 36, and here we get 4 into 1 into 4 is 16. So the answer, the discriminant is 20, which is greater than 0. So hence the discriminant, the root is real, rational, and unequal. Now we have to solve the given equation, given quadratic equation, which is x squared minus 6x plus 4 is equal to 0. Now to solve, to verify the result of the quadratic equation, we can solve this quadratic equation using quadratic formula. We know that the quadratic formula is x is equal to minus b plus minus b square minus 4ac under the root divided by 2a. So we can write the values of a, b, and c from here in a quadratic formula. So if we put the values of b, which is minus 6 plus minus 6 whole square minus 4 into 1 into 4 under the root divided by 2 into 1. So we get minus into minus plus 6 plus minus 36 minus 16 divided by 2. So we get 6 plus minus under the root 20 divided by 2. Now we can write 6 plus minus 4 multiplied by 5 divided by 2. So from here we can write 6 plus minus under the root 4 to under the root 5 divided by 2. So we get 6 plus minus 2 into 5 divided by 2. So from here if we take 2 is a common, so we can write 3 plus minus under the root 5 divided by 2. 2 is cancelled with this, so we get 3 plus minus under the root 5. So the solution is 3 plus under root 5 and 3 minus under root 5. Hence the root is real, unequal, and rational, and the result is verified. So the root we already find out it's real, unequal, and rational, and we verified the result by solving the quadratic equation. So the result is verified. and it's all about this topic.